Advanced Algebra 2, Transformations of Quadratics, Concept 6, and this is part 2 of the notes. We're going to continue these notes by now doing multiple transformations. So if you look at function number 1, g of x equals x plus 3 squared minus 2. So let's identify what's going on. I notice an h and a k value, so that means I'm going to have shift left or right, up or down. Since I have a plus 3, I know that this is going to shift, it's going to translate 3 to the left. And since I have a minus 2, it's going to translate 2 down. So let's write our h and our k values. So our h is negative 3 and k is negative 2, which is our vertex. So let's place that vertex value in the middle of our table, and then place 2 x values in the negative and 2 in the positive direction and plug them in, and you'll see those symmetrical y values. And now graph those points, and you'll see a parabola that has shifted 3 to the left and 2 down. The axis of symmetry is that vertical line that goes right through the vertex, so it's the equation x equals negative 3. Our domain, we can plug in any real number for x and get a real number out. Our range is limited though. The only y values used to create this curve are the ones that are greater than or equal to negative 2. Now if you look at the equation on number 2, even though we only have 2 parameter changes, our a and our h value, we actually have 3 transformations. So we'll have an x-axis reflection and a vertical shrink by 1/2. Our h value is positive 1, so we will shift 1 to the right. So let's identify our h and our k values. So h is positive 1 and k is 0. So we'll place that in the middle of our table. That's our vertex. And then 2 values in the negative and 2 values in the positive direction. When we plug those in for x, we get those y values. When you graph those y values, you'll see a parabola that is reflected across the x-axis and shifted 1 to the right. It's also a little wider than the parent function. Our axis of symmetry, again, goes right through the x value of the vertex, so it's the vertical line x equals 1. Domain is all real numbers, and our range is y is less than or equal to 0, because only those values are being used in the graph of this quadratic. Now let's just move away from looking at the graph or graphing, and let's look at the equation. So we're going to pick out our parameter values, a, h, and k, and then describe the transformation. A is positive 3, h is negative 2, and k is 1. So my positive 3 for an a value will create a vertical stretch by 3. The graph will get narrower. My h value of negative 2 shifts the graph 2 to the left, and my k value of 1 shifts it up 1. So our vertex is the point negative 2, 1. Now number 2, this is a case again where we just have 2 parameter changes but 3 transformations. So a value is negative 1/5 and h is 5. So there's an x-axis reflection. A vertical will shift 5 to the right, and then a vertical shrink by 1/5. And then finally our vertex is the point 5, 0. So now let's work backwards. Let's look at the graph and then write the equation that models it. So I'm going to start first by identifying the vertex. Now notice the scale is by 1/2. So the vertex is at the point negative 3, negative 2. And right away that means I know 2 of my parameter values in my quadratic equation. I know h and k. Now let's figure out the a value. So in the apparent parabola, from the vertex, we would move over 1 to the right and up 1 to get onto the curve. So that's what's happening here. So that means our a value has not changed. It's 1. So now we know enough to write the equation. So y equals 1 times x minus a negative 3, but I can rewrite that as x plus 3 squared minus 2. Whoop. Yep, I think that's all. All right, so last example. Let's identify the vertex here. And again, notice your scale is by a half. So this is the point 0, 2. That's my h and my k value in the equation. So now I'm going to identify my a value. So how many do I need to step over and then how many down to get to the curve? So if I step over 1, I only step down a half. So that means my a value is 1/2. I also notice this parabola opens down. So that means my a value is negative. So my equation will be y equals negative 1/2 times x minus 0 squared plus 2. Now we don't want to leave our equation like this because we can clean up our x term. So x minus 0 is simply x, and then we can just write that as x squared plus 2. All right, this concludes the Part 2 notes of Concept 6, Transformations with Quadratics.